two particles of equal mass m moving with equal speeds v along paths inclined at 60 degrees to the x-axis shown collide and stick together. Their velocity after the collision has magnitude. To find the magnitude of the velocity after the collision, you'd have to use the conservation of momentum. So before, there are two particles, so you'd have m1v1 plus m2v2 equals the combined mass. So m1 plus m2 times the velocity. And since it's two-dimensional, you have to break it up into components. And the first thing you could realize is that they're both they're both moving to the right, so they have the same x component, but their y components would be equal and opposite, so they end up canceling out. So over here, you'd have to find the cosine to get the x component for both of them. So for the first one, so the cosine of 60 is a half. So it's basically and you combine it, it's 2 equals m1 plus m2. Since they have the same mass, you can combine them to get that. And you're going to divide out to find this velocity. Bye. So the main thing you had to understand was that the y momentum was equal and opposite for those two particles, and they had the same x momentum because they're both moving towards the right. So the sign, like if you were to find the x components, they'd end up canceling out because they were equal and opposite. Yeah. So in this problem, there are two balls that are on a horizontal tabletop, and you want to find out what diagram would best represent the motion of the y ball after an elastic collision. Both balls are identical, so, and they didn't give you a mass, so you can plug in 1 kilogram when you're solving for the conservation of momentum on the x and y axes. So for the x-axis, you'd have to find the x component of ball x. This is velocity, so we have to use trigonometry. So 6 cos of 53 gave me 3.16. And the y component for ball x, doing a more trig, 6 sine 53 gave me 4.79. But before that, when you're finding the x velocity for ball y, you plug it into the conservation of momentum formula. So the mass of ball 1 times its velocity plus the mass of ball 2 times its velocity equals the same thing after. So 10 plus 3.16 equals 3.61 plus v2, and v2 is the velocity of ball y. So it ended up being 7.61. And then on the y-axis for ball y, the y component would be found by determining what the y component, the y velocity of ball x was before. Since it was only moving horizontally, there was no y velocity, so 0 equaled the sine of the 6 meters per second, so 4.79 plus the velocity of ball y in the y direction afterwards equals 0, so negative 4.79. So after finding the x-axis, the x component, velocity of ball y, and the y component, you could draw a diagram representing those values, and to find the resultant velocity, you could do the Pythagorean theorem. So you plug in the x velocity plus the y velocity squared equal to c squared, and you take the square root, and you'll get 8.99 as your velocity. And to find the angle, you take the arctan of the opposite side over the adjacent to get 32.19. The answer choice that was closest to my work was C, 37 degrees and 8 meters per second. There might be some differences because of the rounding, you know. Okay, so in this question there are two masses moving horizontally to the right with different speeds, and they eventually collide, and the question asks for what is the kinetic energy after the collision. So since they collide, we're going to have to use the conservation of momentum formula equation. So we have mass 1 times velocity plus this particle, this mass times velocity, to equal the combined mass times the final velocity. Since they didn't give us any set numbers for the mass or velocity, we could plug in 1 for the mass and 1 for the velocity. So this is what happens. We'll move on. Eventually we get 2/3 to equal the final velocity after the collision. And then to find the kinetic energy of the combined objects, we'd have to plug it into the EK, the kinetic energy, which is 1/2 the mass times the velocity squared. So 1/2 the combined mass of 3 times the velocity afterwards, 2/3 squared. We get 1/2 times 3 times 4/9, equaling to 12/18, which simplifies to 2/3. And then eventually the answer choice would be 2C, 2/3 mass times the velocity.